Okay, so in this video, we are going to discuss how to um, do the mathematical operation in LabVIEW, how to evaluate different formulas, equations, so on and so forth. So as I was discussing in my last video, as far as the submission of your exercises, your homework is concerned, make sure you save all files in version 13. And for that, if you're using any version higher than 13, and most likely you will be using 2020, make sure you go to save for previous version and choose version 13 from LabVIEW version. All right. And if you need more information, make sure you watch the previous video, which is creating a VI and homework submission. All right. So let's look at mathematical operation formulas, evaluation of equations and stuff like that. So again, um, we created this simple switching exercise as our first exercise. And if, of course, you will have more than one program every week to submit. So let's say if you have two files, if you have two programs, three programs, four programs, you can create a separate VI for each one of them. Name them your first name underscore last name underscore exercise, number of the exercise, or you can put all of them in one VI as I'm showing you right now, and then you can just put your name, first name underscore last name underscore exercise, and then all the exercises. Let's say you have 4 exercises, then you can put exercise 1, 2, 3, 4, or 1 dash 2 dash 3 dash 4, or 1, actually underscore will be better, 1 underscore 2 underscore 3 underscore 4, all of them. And make sure when you submit your homework, write the exercise number by double clicking anywhere on the front panel. Double clicking there, it's going to convert into text tool. Your mouse will convert into text tool. Write down the exercise number, give a brief description of what that control system is going to do. Like I did, control of an LED with a toggle switch. Exercise 2, evaluation of a mathematical function fxy equals 4x plus 3y plus 6xy minus 7x cube. Okay, so if I have to create this exercise, close this. All right, I'm going to go to the Express library. Now remember, Express library is one of the most commonly used libraries. Now, when we are, and again, a lot of stuff is given in the tutorial, so I want you to read the tutorial very carefully, because all these mathematical operations given in detail with screenshots and everything, and I don't think it's going to be hard for you to understand those things. I'm explaining in videos, of course, in detail, but your exercises are in the tutorial. I will touch upon those exercises as well. But a lot of stuff is given in the tutorial, so make sure you read it. And videos are good. Videos are supplementing the tutorial. If you understand stuff from the tutorial, you don't really have to watch the videos. But if you don't understand something, make sure first you watch videos and then ask me if still something is not clear. Many times students don't watch videos, something they don't get from the tutorial, they just come and they ask me something that I have already explained in videos. So make sure I'm creating these videos for you. If you don't understand something in tutorial, please go and watch the video first. If you don't find your answer, feel free to contact me and I will be happy to explain anything that is not clear. All right. So let's say we want to create a control system such that you have two inputs. You have an x, you have a y, and you have an input x. Two inputs. You have to understand, before you create a control system, you have to understand how many input, output, what are the things are part of that control system. So if you are creating a control system that will implement this system, this formula, this equation, I'll call it equation, it's not a formula, that will implement this equation. You know that you need to give a value of x you need to give a value of y. So wherever you have x in the equation, x will be substituted there. Wherever there y is in the equation, y will be substituted there. And then you have output f of xy, right? F is function, just a variable, function of xy. So you need one output variable and you need two input variables here, right? One output variable to see the value, observe the value of the output fxy, and to enter the values of x and y, you need two input variables, x and y. Now, many times students make mistake. They put x, they put y, they put xy, and sometimes they also put x cube. So they put four input variables. Remember, they're not four input variables. X is one variable, y is the other variable, and wherever you see x, the same x is used. Wherever you see y, the same y is used. All right. So to give input values, you use number controls or numeric controls. So there is a simple number control, and I'm going to use that. I'm going to put it vertically. Let's say this is my x and this is my y. Okay, my x and my y. And let me do one thing. I'm going to put the other window next to this window, so you can also do the function diagram, the block diagram, and front panel side by side or right and left. I'm going to put them right and left, so you will see what's going on over there as well. Okay, this was my first one, so I'm going to move it up, and this is my second one. All right. So as you put x, you have the corresponding block. As you put y, you have the corresponding block. Observe that the data type of this is DBL. DBL stands for double floating point. Double floating point, right? So this is not true and false. That means these two cannot interact with each other because they have different data types. So these will be used to enter the values of x and y. Over here, you have the toggle increment and decrement, and if you want, if you do right click, you can actually close that increment and decrement if you don't want it to be. I will keep it. I mean, you can always enter number here through your keyboard. I'll just keep it. If I want to use it, I'll use it. Okay, and the next is you want to see the output fxy. So to see the output, you have numeric indicators. So you're going to go ahead and let's just use one numeric indicator right here. And this is my f of x comma y. Okay. All right, what we are doing, we have already explained here. This is what we are doing. Evaluation of fxy equals 4x plus 3y plus 6xy minus 7x cubed. Right? If not, then you can also write the same formula over here. 4x plus 3y plus 6xy minus 7x cubed. 7x cubed. Okay, so that's my fxy. I'm going to move it in the center a little bit. All right, so that's all you need as far as front panel is concerned. You have two inputs that you are going to change. You have an output that will show you the result of these two inputs. Now all the logic is going to be done in your block diagram. Okay, so this is my second. Okay, all right. So what is the logic? Well, logic is what you have to implement, right? You have to multiply. Oops, I put equal over here. I'm going to go ahead and change it to plus. Okay. So you have to multiply x by 4. You have to multiply y by 3. You have to multiply x and y together and then multiply the product by 6. You have to take the power of x, 3 cube, multiplied by 7, and then you have to add all of them and subtract this. That's what you have to do. So let me show you how to do that. first you're going to multiply x by 4. Okay, so we're going to go to the express library again. And in the express library, the most commonly used sublibrary is arithmetic and comparison. Under arithmetic and comparison, you have multiple function blocks, sublibraries. The one that is very commonly used, math, numeric. We will also use comparison, we will also use Boolean, we will also use formula. But right now we're going to use numeric, and we're going to pick a numeric constant. Observe all the functions here: addition, subtraction, multiplication, division, increment, decrement, compound arithmetic. We're going to choose numerical constant, number constant. And we are going to put here and give a value of 4. Okay. All right. And now we have to multiply that 4 by x. So we're going to take a multiplier. We're going to put it here. 4 goes in one input, x goes in the other input. And the output of this is going to be 4 times x. Okay. Next, we're going to do 3 times y. So again, we're going to grab a numerical constant, give it a value of 3, take a multiplier, put it here, this, and this. All right. 6xy. All right. Now 6xy means what? You have to multiply first x and y. How you can do that? You can grab a multiplier. You can put 1 here, and you can do 1 here. Right? X is coming in one input, y is coming in the other input. Output will be x and y. And then you have to multiply that product by 6. So you can grab another multiplier. X and y goes here, and then you can grab a 6, give it a value of 6, and that is going to go here. Okay. So the output of this is going to be 6xy. Now, you can also, it's always wise if you have a bunch of wires, it's always wise to write down what is flowing in different wires, just to make it easy for you to understand. For example, here I have xy coming out of this, right? This is y, this is x, xy is coming out of this. When I put a wire over here, I'm going to put, let's say, this is 4x. 4x is going to come out of here. This is 3y. 3y come out of here, right? And likewise, I can do 7x cube. All right. Now, there is a square over here. Remember, if you need a square only, not cube, a square, you can use this square function. Now, to use a cube function, let's go back and go to mathematic exponential. And in exponential, you can see x to the power y. This can be used for any power of x. So if I put it right here, and anytime you use a block and you don't know, observe there are 2 inputs and you don't know which input is what, just put your mouse on that input and see. The top one is y, that means power. This is x to the power y, right? So the first one is y, the top one, and the bottom one is the base x. Or you can also look at the help of that. If you open the help of that, it will show you that the top one is where you have to attach the power, that is cube, and the bottom one is where you have to attach the base, and the output is going to be x cube. And the help will also show you examples and all those things. So help is a very powerful tool in LabVIEW. So what I'm going to do, x cube, I need a cube. So I'm going to go back, I'm going to go to arithmetic comparison, numeric, I'm going to grab a numeric constant, put it here, give it a value of 3, which is cube, connect it to the power y. And then x is right here. This is my x, right? So the output of this is going to be 3 x cube, x to the power 3. and then I have to multiply this by 7. So I'm going to go ahead and grab another constant. I'm going to give it a value 7. I'm going to grab a multiplier. Now, sometimes it's very cumbersome to do things in graphically. As you can see, this is a simple program that you can write in MATLAB or some to implement this equation, but you can see that in terms of blocks, you have to put a lot of blocks. So now the output of this is going to be 7x cube. And you just have to double click and then you can write anywhere. And now all of them are being added and subtracted. Okay, so that means you have to put one addition block. This is the addition block right here. You have to put one addition block, second addition block, and then a subtraction block. And the output of that is going to go into this. Okay, so you're going to put one addition block, let's say 7x cube, and oh, that's the subtraction, so I'm not going to add this here. Okay, you can do right if you delete anything, just right click and then do remove loose ends, or you can just hit delete. So I'm going to do add, and let's say I'm going to add these two. This is what is this? 6xy. 6xy, 3y times 3y. So this is my 3y. Let me go ahead and do it from here. Actually, let me move this up. And then connect the 3y at the bottom. That's it. Oh, I didn't move it up. Let me delete this. Okay, let me go ahead and connect this here and connect this right here. So this is 3y and this is 6xy. So you know what is coming in this addition block. And now the output of this has to be added in 4x. So I'm going to move this up a little bit, do another addition block here. Where is my 4x? This is my 4x right here, right? So I'm going to do, as long as it is not making a node, that means it is going on top of that wire. It is not connected to the wire. Anytime you see a node, that means it is connected to a wire. Okay, you know, it's not very good to run a wire on top of the other wire, but you know, really nobody is going to come and check this. Everyone will be interested in the control panel. Only I will be checking it if you are making a mistake. And then 6sy is added here. So this is your 4x, and this is your 3y plus 6xy, right? So that's going into the addition block. So this whole thing right here, this whole thing is coming out over here. 4x plus 3y plus 6xy. And now 7x cube has to be subtracted from there. So I'm going to grab a subtraction and I'm going to put it here. This is going to go on top. And this is going to go at the bottom. Okay. The 7x cube, this is 4x plus 3y plus 6xy, and then the output of this is going to go here. Okay. Now looks pretty messy. Now let me tell you, to keep this mess a little bit less messy. And a way to keep it a little less messy is to use compound arithmetic. Right now I did not use compound arithmetic because I just want to show you individual function blocks, how to use individual function blocks and write down this equation. But if you use compound arithmetic, observe you have the positive sign over here. Now you can stretch it, and it will increase its inputs. So right now you have what 5 inputs. So that means all 5 inputs can be added together by one block. So instead of adding 4x plus 3y, so instead of using this block, and where is my third add block? Do I have to? Okay, I have only 2 blocks. Instead of adding these 2 blocks, I can just use compound arithmetic, and I can add 4x in the top, and I can add 3y in the bottom, and then I have also 6xy over here, right? So I can get rid of this addition block and this addition block, and I can directly add all 3 of them, 4x plus 3y plus 7x, 6xy. Also, if you right click, you can change the mode to multiply, and then you have the Boolean operation AND, OR, and XOR that you studied in PSpice. You can change it to multiply, and then my 6xy, I don't need 2 multipliers. I only need 1 multiplier. 6xy, I have 6 times x, and then I have, where is the y? Yeah, right here. So I have x times y and 6 times x. So instead of these 2 multipliers, I can just use 1 block, and I can have 6 coming on top, or x coming on top, y coming at the bottom, and 6 coming at the bottom. Or 6 coming on top, x coming in the middle, and y coming in the bottom. And all 3 will be multiplied together, and the output is going to be 6xy. So to make it clean a little bit, you can use compound arithmetic block. I'm not going to show it right now, but I'm just telling you that compound arithmetic is present over there. And if there are multiple products or multiple additions, you don't have to use individual addition or individual multiplication blocks and use multiple of them. Instead of that, just use a compound arithmetic block and then expand it to, if you are multiplying 4 things together, 4 numbers or 4 variables, just expand it to 4 inputs and connect one input to each of the one variable to each of the input, and the output is going to be the product of all 4 variables or 4 constants or constant and a variable, whatever. And likewise, if you want to add, then right click, change it to add, and do the same thing, stretch it to accommodate your input values, and then all of those values will be added together, and the output is going to be the sum of all those things. Okay. Now again, I'm not going to touch this right now. This control system is done, so I'm not going to touch that. So we're going to go ahead and run this. I'm going to go ahead and save it first, and then I'll just run continuously. And let me close this. And then if you change x and if you change y, you can see that fxy is changed based on whatever the value of x and whatever the value of y. You can do decimal values, floating point. You can do whatever value you want, right? So this is what you are presenting to your client, that whenever, or this is a small program that you can create, a game that you can create, that anytime you change the value of x and y, like on many websites you must have seen that you change some numbers and then it gives you an output. So pretty similar to what you see on the websites. You change x and y values and it will evaluate this equation and show you the output. And this is the logic behind all that, right? Logic behind everything that's going on. So I hope you would have understood what's going on here. Now remember, if you you have to stop, then make sure to stop it. Once you're running it, you can also run the first, because it's the same program, and you can run the second. And again, if you want, you can put the third exercise here, fourth exercise here. Just change the name to your first name underscore last name underscore exercise 1, 2, 3, 4, or whatever you want to give. And if you are submitting each exercise in a separate VI file, then of course you have to give the name accordingly, exercise 1 for the first one, 2 for the second one, and so on and so forth. So I leave it on you how you want to do your homework and submit your homework. Okay. Now if you close, remember if you close the panels, right now I have closed the control panel. I don't have the, well, I do have the function palette, but I can close that as well. Remember, anytime you can, you close any palette, go to view, and from that you can open the palette, control palette, and then go to view and open the function palette. Function palette, remember, is associated with block diagram. Control palette is associated with the front panel. I'm just gonna close it. Okay, let me go ahead and then you are doing this exercise. So pretty similar to what I showed you right now. Actually, it looks like very similar. Different formula, but pretty similar. So this is pretty similar to what I showed you. This is one of the exercises that you are doing. It's the second exercise that you're doing. So basically, you are converting temperature in Celsius or centigrade into temperature in Fahrenheit, and this is the formula. So basically, like you are implementing this formula, now you have to implement this formula. So you have two inputs. You have you have one input, you have the temperature in Celsius as your input, one input. And for that, you are going to use a knob, right? A knob. So enter temperature in centigrade or Celsius, 0 degrees to 100 Celsius with a knob. So let me show you, go back. Where's the knob? Go to, well, we can just use here, numeric, and you can have a knob, right? There, it's also in Express. So this is what you're going to use for Celsius, right? So I'm going to change that to temperature in centigrade, right? Now you have to give the input from 0 Celsius to 100 Celsius. The default values are 0 to 10. All you have to do, either right click, go to properties, and change the scale 0 to 100. Or you can just click on it and then change it to 100, and it's going to adjust itself, as you can see. Okay. All right, and then you are going to have the output, equivalent output in Fahrenheit. So you're going to use a thermometer to display the equivalent output in Fahrenheit. And where's the thermometer? Again, it's in the numeric indicator. So if I go to the same folder, where was I? Boolean numeric right here, and then thermometer is right here. So you can use thermometer, and then you can write down temperature in Fahrenheit. I'm just going to write down F. And remember, 0 degrees Celsius is 32 Fahrenheit. So make sure change the lower range to 32, and 100 degrees Celsius is 212 Fahrenheit, so change the upper range to 212. So when you dial, when you change this dial, it will go from 32 Celsius to 212 Celsius. Make sure if you are putting it in the same same window, same front panel, make sure to put a line over here. Put down that description of the exercise. Well, you have to put the description of the exercise, whether you are doing in the same one or separate files. Make exercise number 3 or whatever the exercise number is, exercise number 4, conversion of temperature in Celsius or centigrade into temperature in Fahrenheit. That's the description of the exercise. All right, these two blocks are the corresponding blocks for temperature, for the knob, and for the thermometer. Observe the thermometer is input block where the input is coming, or output block where the input is coming to present the output, and temperature knob is the output block where it is sending the value of the temperature in centigrade. So you are going to basically use these two as you created a logic over here. Then you're going to use those two blocks and you're going to implement this formula. Okay. And exercise 5 is basically you have a series circuit. You have a voltage source, you have two resistors as you did in PSpice, and you have to use a voltage divider rule between the two resistor and the voltage source. And the voltage divider rule, you have to find the voltage across R2. And to find the voltage across R2 using voltage divider rule, this is the formula. The voltage across R2, which is across R2 right here, is equal to R2 over R1 plus R2, values of R1, R2 times the value of the source Vs. Okay, this is how your front panel is going to look like. You have a dial, again numeric control, dial is in numeric control. You have two numeric controls here, like we used in our program, these type of controls, this. And let's see, and then you have a numeric indicator, which, and the arrow basically is showing that this is the voltage that we are measuring. All right, this is all decoration. This is in the modern decoration, right here it says modern decoration. So all these lines I drew in the decoration libraries. I drew the lines, I put these boxes, I wrote down R1, R2, and the ohm symbol is basically, the way I put the ohm symbol is it's uppercase W in symbol font. So you write down uppercase W and then go to symbol font, highlight W, and then convert it into symbol fonts. Is going to convert into the symbol of ohms, omega, uppercase omega, Greek letter. And then these are numeric controls, so you can change the values of R1, R2, and you can move the dial, and then whatever the voltage according to this formula, whatever the voltage is dropped across R2, it's going to show in this numeric indicator. So you are basically implementing this formula the same way that we implemented this formula, right? So it's much easier because it's only division and addition and multiplication. So these three exercises you're doing, and also I'm not going to go over it. This is already explained in tutorial. Read it. Basically how you do the descriptive information. Actually, I showed you the descriptive information and the documentation. Actually, descriptive information is given in the tutorial. I just showed you that how to put the what you call a description, how x cube, 7x cube, how it is flowing, the signal is flowing, and all those things. So basically, in this example, I'm showing you how to create a control system to solve the quadratic equation. You know the quadratic equation, ax cube plus bx plus c equals 0. That's the quadratic equation. And to find the roots of that equation, that is to find the value of x for which the equation is going to become 0, which are called roots of the quadratic equation. Quadratic equation has two roots. Those roots can be either real numbers or imaginary numbers, and this is the quadratic formula that is used to find the value of these roots. X1 is negative b plus square root of b square minus 4ac over 2a, and x2, which is root 2, is negative b minus square root of b square minus 4ac over 2a. Okay, so this is the formula. These two formulas you are using to find root 1 and root 2, and your input is the quadratic coefficient. So ax square plus bx plus c, coefficients are a, b, and c. So this is, although it is solved, I want you to do it, and you have to submit this as well. All right, so here I'm telling you how to put the help or documentation, so go through it. It's pretty straightforward. And go over this example. It's solved in the tutorial, and you have to do this example. This is the block diagram, but again, you don't have to copy the block diagram. Remember, you are implementing these equations, two equations. So once you do exercise 2, exercise 3, 4, and 5, you will have good idea as how you are going to implement an equation or formula, and then hopefully you will be able to do it without even looking at this. Once you implement this, you can check it. That should be okay. Now remember, you have to go all the way until the page 16. Or in other words, your quadratic equation solver should solve both real roots and imaginary roots. So observe, these are imaginary roots or complex numbers, right? So your quadratic roots can be either real or complex. So you should be able to solve both. Now how are you going to get the complex roots? It is given right over here. All you have to do, that the program that you're going to create, wherever you have the square, right click that is square, and then choose complex double. right here, square root function block and the number indicator block, two things. So use complex double, right? This is square root, right click, complex double. And similarly, numeric indicators, root 1 and root 2. Right click and choose CDB, representation CDB, which is complex double. If you do that, then your program should be able to display real root as well as complex roots. If you don't do that, if the root is complex, it's just going to show you NaN, not a number, because it will not be able to handle the complex numbers. So make sure again, square root, right click, choose complex double. And likewise, indicators, right click, complex double, and then it should be able to show you the complex roots as well as the real roots. In here, I'm showing you the real roots right here, and then I'm discussing the complex root right here. So this is also something that you have to do, and you have to submit it with your homework. And this finishes this video lectures. Became a little longer, but this is the initial lecture. So I hope you will watch it if you don't understand something in the tutorial, and hopefully this will help you figuring out a lot of stuff. So I will see you with the next lecture, which will be